All right, so this is going to be more multiplying, but instead what we're calling it is multiplying conjugates. All right, now the reason it's called a conjugate is because everything is exactly the same. So we have a 5 square root 3 and a 5 square root 3. We have a square root 2 and a square root 2. The only difference right now is this middle piece. That operation, it went from a plus to a minus. So if you notice that everything looks exactly the same, except for the operation separating those two terms, we're going to call it multiplying conjugates together. All right? And when you multiply conjugates, the only thing you need to multiply are your two first items together and your two last items together. You only need to multiply the like terms. So I'm going to take 5 root 3 and multiply it to 5 root 3. That's 25 square root 3 times 3. I'm going to multiply my square root 2's together. One's positive, one's negative, so it's going to become a minus, and it becomes 2 times 2 underneath that square root. Now, remember, these are square roots, so we got to find sets of 2. Here's a set of 2, so this is really the same thing as 25 times 3. Here's a set of 2. We're really just subtracting 2. 25 times 3 is 75. We're going to take 75 minus 2 and get 73. So when you multiply conjugates, you actually are going to get rid of some of these square roots, all right? Because we are multiplying like square roots together, all right? So we always want to multiply our firsts together, multiply our lasts together, and that's how you multiply conjugates. Now, this only works. You are only going to do this if they are conjugates. So you have to recognize that. Recognize everything is the same except for the operations. And if that's true, then you can do this. If not, multiply everything out, distribute it all, and you're going to see that you're eventually still going to get 73. This is just a more efficient way to be able to solve all this stuff. But that's multiplying your conjugates.